problems that should be looking kind of familiar to you. But let's get going on them. The first one is a couple of those radicals. We're adding a couple of radical numbers, the square root of 18 and the square root of 2. So what we're going to try and do is see if we can simplify the square root of 18 and get some number times the square root of 2. So let's see how that works. So I'm going to come over here where I got a little room here and factor 18, and that comes out to be 2 times 9. And that factors a little bit further into 3 times 3. And so 2 times 3 times 3. And so I've got a pair. And one of those will come outside of the radical. Kind of keep in mind we've got a radical going all the way down through here. So the 3 comes out in front. And then I'm left with the square root of 2 inside because it didn't have any matching pair. So that really gives me 3 times the square root of 2 plus the square root of 2. And since there's no number in front, we know that just means it's a 1. So 3 plus 1 is 4 times the square root of 2. All right, nice work, not too bad. Okay, tell whether the angles are complementary, supplementary, or neither. So in order for them to be complementary, the two have to add up to 90 degrees. Well, this one's already bigger than 90, so if we added them together, we know it would be bigger than 90, so it's not complementary. How about supplementary? If we add them together and the total comes out to be 180, so let's try adding them together. 92 and 88. 8 plus 2 is 10, so 0, carry the 1. 9, 10 plus 8 is 18. Oh, look at that. Between those two angles, they add up to 180. So that would mean that they are supplementary. So those two angles are considered supplementary. All right, on this next one, we got one of those vertical angle diagrams. Vertical angles. So we know that the angles that are straight across on these intersections are equal to each other, and that angles adjacent to each other combine to give you 180 degrees. So we know then that x is equal to 180 minus 57. And when I do that on my calculator or whatever addition or subtraction device that you have, you end up with 123 degrees. So that's the answer for x, 123 degrees. And 123 plus 57 does in fact equal 180 degrees. All right, so let's move on. So today we're going to be naming triangles and doing a little work in that respect. Now before the last few lessons, or at least our last lesson, we were talking mostly about just specific angles, and now we're going to be kind of combining them together. So we know that if we have an angle or a triangle that has all acute angles, that's considered an acute triangle. If you have a triangle that has one right angle in it, a 190-degree angle, that's considered to be a right triangle, even though one of them's 90 and these other two would be acute angles. Because of the 90-degree angle, this is called a right triangle. If your angle has one angle that's bigger than 90, that's considered to be an obtuse triangle. So there you go. All right, some other classifications. If you have a triangle in which all three sides are a different length, as indicated by these little marks, 1 mark, 2 marks, 3 marks, all sides different length, that would be considered a scalene. If you have a triangle that has two sides that are the same length, like you do in this one, that's considered to be an isosceles triangle. And lastly, if you have a triangle where all three sides are the same length, that's considered to be equilateral. Okay, classify scalene, isosceles, and equilateral triangles by side lengths. Okay, so if you look at this one, you got two sides that are the same length, so that's going to be isosceles. This one you got all the sides are the same, equilateral. This one you've got three sides that are different in length, which would be considered a scalene triangle. Oops. Okay, moving ahead. Let's try another one. This first one, all three sides of the triangle are the same, so equilateral. This next one, you got three different sizes, so that's going to be scalene. And this last one over here, you have two sides that are the same length, so that would be isosceles. All right, let's keep on moving. Okay, now so you may have done this experiment before, but you might want to try this sometime. Just make a little triangle and then mark each corner or label each corner with an A, a B, or a C. Then if you cut each of these corners off and lay them out on a straight line like this, you'll find out that the three corners on this triangle add up to a straight line, which makes that a 180-degree angle. And that's why you can tell that the three angles of a triangle add up to 180 degrees. All right, so basically that's what we came up with that little proof, and that is that all of the angles of a triangle add up to 180. Now, we've seen this before. We've been practicing that as well. So let's give it a little more practice. For each of these problems, find the value of x, depending on what you're given initially. So in order to find x, you're going to have 180 degrees for your total, and then you're going to subtract off these two amounts of the two known angles, and that will give you the last angle, which is x. So if you do 180 minus 55, then that's going to give you 125. And 125 minus 28, that's going to leave you with 97 degrees. So x in this case would be a 97-degree angle. All right, pretty straightforward. Okay, in this next one, you know that you got a 59-degree angle. And because of that little red box in the lower left-hand corner, you know that's a 90-degree angle. And if you add those up, you end up with 149 degrees. And you subtract that from 180. So 180 minus, that's a subtraction symbol, minus 49 would be what? 4950, so that's going to equal 31 degrees is what we're missing. So x out here is equal to 31 degrees. Now this almost looked like an equal sign. I just want you to make sure you remember that was a subtraction sign. Okay, finding an angle measures of a triangle given two angles. All right, so on Alex, this is what it'll look like. So you'll pretty much do the same thing. You'll have 66 and 50, which when you add them together, you get 6 and 11, so 116. And you'll subtract that number from 180. And so that would give you, let's see, if I add 4 to 116, that would be 120. And I need another 60 to get to 180, so this would be 64 degrees. So our last angle over here would be 64. So that would be a acute triangle. All right, find the angle measure of a triangle given two angles, find the value of x. Okay, so we know that the three angles have to add up to 180. So 106 and 31 certainly add up to 137 degrees. And we subtract that from 180. So what's 180 minus 37? And that turns out to be 43 degrees. All right, I'm kind of liking this so far. This has not been too bad. All right, now we can also do this. What do all the three angles in a triangle always add up to? Well, that's 180 degrees, right? So we're giving you three angles here, and we want you to add them up, and if the total equals 185, then it is the measures of a triangle. So let's start with the bottom. I notice I've got 113 and an 85. Without even starting, I know that if I add those two together, I'm going to be over 180, so that's not going to work. So now we can try some of these other ones. Oops, go back. What we're going to do is get a calculator. I got a little carried away, so we'll grab our calculator, and let's go ahead and add those three up. So 95.1 plus 27.8 plus 67.3 equals 190.2. So this is not a triangle. Let's go to the next one, the last one up here. So clear this one out. Up at the top we got 82 plus 36 plus 62. And those three add up to 180. So that would be the angles of a triangle. All right, so that's the idea here. Okay, moving on. And there's all we needed to learn about so far in this lesson. So the assignment is on Alex, called Classifying Triangles. Good luck. We'll see you next time.